In the previous video, we looked at dividing radical expressions by multiplying by a special form of 1 for denominators with only one term in them. In part 2, we're going to look at two terms in the denominator and how we can take care of the radical that occurs there. Here I've got some examples of conjugates, and you can see in every single case how they differ is only by the middle sign, not the first sign. All of the first ones are positive. It's the middle sign. And that's why we call these conjugates and not opposites. Opposites would be an opposite to an expression, putting an example up top, would be -1 minus square root 2. The opposite being opposite in sign for both signs, not just the second sign. Let's use this idea of an expression with its conjugate to rationalize this denominator, 1 divided by 1 plus square root 3. We're going to multiply by a special form of 1 first. Let's enlarge this so we can see it a little bit better. And that special form of 1 is going to consist of the conjugate. We're going to put whatever's in the denominator, we find its conjugate, and we use that to form our special form of 1. So 1 plus root 3 will turn into 1 minus root 3 for the conjugate, and then we match it up top for a special form of 1. It has to be identical to be 1. Once we do that, we can multiply straight across just like before. 1 times 1 minus root 3, 1 minus root 3. On the bottom, 1 plus root 3 times 1 minus root 3. We need to multiply this out. Let's do a box method on the side. 1 plus root 3, 1 minus root 3, 1 root 3, negative root 3, negative root 3 squared, which just turns out to be negative 3 because the square root and the square will cancel. And then we can write it all out. 1 plus root 3 minus root 3 minus 3. And you may see it. This will always happen if you choose the correct conjugate. The middle terms cancel. And we are left with 1 minus 3, which turns out to be negative 2. So in our fraction up here, 1 minus root 3 over negative 2. That could be acceptable. A lot of times we don't like the negative on the bottom, so we could move it up top. Negative 1 minus root 3 over 2, which would give us root 3 minus 1 over 2 for a possible final answer. But either of these is correct. Let's look at the next problem together. 4 plus root 6 divided by 3 minus root 6. Here looking at two terms on the numerator and two terms on the denominator. Don't let that numerator trick you though. We only care about what's happening in the denominator. The denominator is the problem. And so the denominator is what we need to fix, what we need to correct. So we look at 3 minus root 6 to achieve the conjugate. To get the conjugate, we change the middle sign to a plus. 3 plus root 6, and we will copy that on top. 3 plus root 6. And then we multiply straight across top and bottom. 4 plus root 6 times 3 plus root 6. On the bottom, 3 minus root 6 times 3 plus root 6. And then two things to multiply out, but also something to think about. With the denominator, this is going to multiply to be 3 times 3, which is 9, minus 3 root 6 plus 3 root 6. The middle terms cancel. And then the last term, root 6 times root 6. That's going to be the square root of 36, which is also just 6. And 9 minus 6 is 3. So the whole denominator simplifies to be 3. On the numerator, we can use the box method. 4 plus root 6 and 3 plus root 6, and multiply these out. 4 times 3 is 12, 3 root 6, 4 root 6, 6 times 6 is 36, square root of 36 is just 6. And then the numerator becomes 12 plus 3 root 6 plus 4 root 6 plus 6. And we can simplify. 12 plus 6 is 18. 3 plus 4 is 7 root 6 over 3. We can leave it like this in one single fraction, or we could split it up. 18 over 3 plus 7 root 6 over 3. The second term does not cancel with anything, so we have to leave it as it is. 18 over 3 is 6. So we could also write it as 6 plus 7 square root 6 divided by 3. But we are going to revisit this idea of a conjugate to talk about dividing complex numbers in just a few lessons from now. We will need the concept of finding conjugates and multiplying by special forms of 1 created from those conjugates for our discussion of complex numbers a few lessons from now.